Hi, I'm Forrest, member of the Teen Advisory Board with the Howard County Library System, and today I'm glad to teach you about the basics of logarithms. So let's get started. Okay, so here's like a short little intro to logarithms. So first, you can think of a logarithm as an inverse of an exponential equation. I'll talk about more of this later on in this presentation, but basically, when you take an inverse, you're ultimately just switching the x and y values. So the function on the right is an exponential graph, and it is defined as y equals 2 to the power of x. So to take the inverse of this, you ultimately just switch the variables y and x, and you would get x equals 2 to the power of y, but we'll obviously talk about this more later on. So logarithms were first invented by John Napier in 1614. There's some stuff about that. Essentially, he just wanted to solve for right triangles with sines, but you can look into that more on your own because this is just an intro. So next, moving on, to understand this, what you need is basically just a simple knowledge of algebra and you'll probably succeed. Moving on to the basics of logarithms. So let's say I ask you, how many of one number do we multiply to get to another number? So for example, how many 3's do we multiply to get to 81? So basically to solve this, you would think like, how many 3's can you multiply by each other to get to 81? And ultimately you would get 3 times 3 times 3 times 3, which would equal 81. If you do it in your head, 3 times 3 equals 9, 9 times 3 equals 27, and 27 times 3 equals 81, so you would get 81. So your answer to that would be, we have to multiply 4 3's to get 81. And ultimately, you would say like the logarithm of this is 4 because it takes 4 3's to multiply together to get to 81. And I'll go over that later in the next slide. So the format of a logarithm. So in the previous problem, we asked like, how many 3's do we multiply to get to 81? So basically you could write this as log base 3, 81 equals 4. We'll go over how that is formatted. I promise this will get easier as you do more problems. But so here's the main problem. I'll be breaking it down into 3 different parts. So on the part on the left, I didn't really include anything because it's something that happens in all logarithm problems. But basically, when you want to take a logarithm, you always add log at the beginning, and then the tiny. Let me skip through. So the tiny 3 over here is what you call a base. So if you had a 3 here, you would say log base 3. If you had a 4 here, you would say log base 4. So I wanna say like, if you don't see a number down here, usually that means the base is 10. So like log no base 81, that would be log base 10 81. So now the 81 over here, we call that the argument. That is basically like what you're trying to achieve at the end of multiplying the 3's together. And then finally over here, the 4 we have is the exponent. And I'll be talking to you about how I'll be explaining why a logarithm is relatively similar to an exponent. So you could also think of this equation as 3 to the power of 4 equals 81. And that's basically what a logarithm is. So yeah. Moving on, how are logarithms related to exponents? So let's say you're given the exponent 2 to the power of 3 equals 8. So obviously this turns into 2 times 2 times 2 equals 8. You can do that in your head. And then moving on, if we look at logarithms, we are given 2 to the power of what number equals 8. And you can convert this into log base 2, 8 of 8 equals 3. So to convert this down into logs, ultimately, you have to look at the exponent. So the exponent that is given you is 2 to the power of 3. With your prior knowledge of algebra, you would know that the base in this exponent is 2. So we put the 2 down here in the log, and and then our exponent 3 on the other side, and our argument 8 inside of here. So basically the logarithm is just going to be trying to find the exponent while providing you an argument and a base. And so the question mark is equal to 3, obviously, because 2 times 2 times 2 equals 8. So next so I just provided a little graphic that I hope will help. So it's basically saying y equals log sub b of x, and x is your argument. You can see it down here. And then b is your base of the exponent that is provided below. So yeah, this is basically like the universal rule of essentially all logarithms, and it may seem overwhelming at first, but with more practice, this is something that you can easily master. Okay, so now we're going to be going into some examples of logarithms. Obviously you can do these on your own, but I just wanted to walk you through some of these problems so the concept is easier to understand. So on the first problem, you're given log base 5 of 25 is equal to y, and they're asking you to find the value of y. So essentially you could rewrite problem 1 as 5 to the power of y is equal to 25. And if you think of this mathematically, doing some mental math, you would know that 5 to the power of 2 equals 25, because 5 times 5 is obviously 25. So that means your answer to number 1 would be y equals 2, and that is ultimately the correct answer. So moving on to number 2, it's asking you log base 3 of 1 is equal to y. So it's asking you, once again, 3 to the power of y is equal to 1. So if you use the rules of exponents or the laws of exponents, you would know that any number to the power of 0 is equal to 1. So ultimately you could plug in 0 as y and you would get 1, because 3 to the power of 0 is 1. So your answer to this would ultimately just be y equals 0. So as you do more of these problems, you would start to notice a pattern here, and you can start catching on to this and ultimately get faster. But yeah, so moving on to number 3, it's giving you log base 16 of 4 is equal to y. So once again, rewriting this into an exponent, you can get 16 to the power of y is equal to 4. Okay, so we have 16 to the power of y equals 4 by rewriting number 3 with log base 16 of 4 equals y. So this is something that's kind of relying on square root knowledge and exponents. So basically, if any number to the power of 1/2, you know that's basically just taking the square root of the number with laws of exponents. So if you can look at the relationship between the two numbers, the base and the argument, you would know that like the square root of 16 is equal to 4. And if you can catch that relationship, you can understand like what y is. And in this case, y is equal to 1/2, because the square root of 16 is equal to 4, and y represents taking the square root of something. So let me write this down. Alright, I hope you enjoyed my short little tutorial on how to understand basic logarithms. Obviously, if you didn't really like catch on to what I said today, you can obviously replay and pause the video, or you can obviously do more practice and hopefully understand the concept in the future. So, thank you and have a great day.